Hey everyone, before the video starts, I'd just like to say that the video was corrupted. I was able to get the audio because I had backups, but the main video was corrupted, so most of what you're going to be seeing is filler. I do still have the pictures and such, so it won't be too out of place. There's just a few things like the animated character which was in here that will not be in here. So, enjoy!
So you want to learn about nuclear proliferation. Nuclear proliferation is the spread of nuclear weapons, fission materials, nuclear weapons applicable technology, and states not recognized by the Treaty of Non-Proliferation of Nuclear Weapons. The treaty states that 5 states are recognized by the Non-Proliferation Treaty as nuclear weapon states. NWS, China, signed 1992, France 1992, the Soviet Union 1968, obligations and rights now assumed by the Russian Federation, the United Kingdom 1968, and the United States 1968, the United States, UK, and Soviet Union. These countries are to have nuclear weapons, but have signed a treaty stating that they will never use them, they will not make any more, and that they will have the right to peacefully use nuclear technology. Now, they may be the only nuclear weapon states, but that does not mean they're the only countries to sign the agreement. The treaty was ratified by every country except India, Israel, North Korea, Pakistan, South Sudan, and Taiwan. North Korea withdrew from the treaty, Taiwan is an unrecognized state, and the rest are all non-signatories. All that means is that they have not signed a treaty which makes them unable to use their nuclear weapon technology in other countries. This is bad in its own respect, as nuclear weapons are one of the most destructive human-made forces on the planet. Now that all the treaty mumbo-jumbo is over, let's talk about what you probably came for, nuclear weapons. Nuclear weapons come in a variety of flavors. The famous bombs dropped in Hiroshima and Nagasaki were called Fat Man, which is dropped on Nagasaki, and Little Boy, which hit Hiroshima. Now to take into account how powerful nuclear weapons are, we're going to be using the Little Boy as an example. The Little Boy atomic bomb is a 9,700 pound bomb that is 10 feet high in length and a width of 7 feet, and a diameter of 28 inches. Its filling was uranium-235, which weighed a total of 140 pounds. The blast yield of the Little Boy atomic bomb came in close to 15 kilotons of TNT, 63 TJ. Now, the Little Boy was smaller than Fat Man, which yielded 21 kilotons of TNT power, which is 88 TJ. Now, let's compare that to the TSAR bomb device, the most powerful nuclear weapon ever detonated. Tsar Bomba was detonated October 30th, 1961, and its kilotons of TNT? 50,000. Its TG is 210,000. See the mushroom cloud? It may look pretty, but that was actually a mushroom cloud from the explosion. You've seen it from 99 miles away. It was 35 miles high at the crown when the picture was taken. Now this chart is special. Remember how I said the Little Boy was even smaller than the Fat Man? The tiny dot in the middle is the Fat Man. Now look at the difference. But that's pretty hard to put in perspective, right? Well, this picture should make it a little easier to understand. See Paris? That's where we're going to put our hypothetical TSAR bomb. Now, the actual fireball explosion is 2.2 miles in radius. That means Paris is basically gone. The blast wiped it out. Now, you probably don't know any of these cities, but they're also gone. The red circle is a total destructive circle and 22 miles in radius. Now, you might think that's not all that bad, but all we're talking about is the biggest explosion. We haven't even taken into account radiation or aftershocks of the bomb size. And radiation does a few things we can take into account, so let's learn a bit about that too. Now, since I brought up radiation, let's talk about it a little. The emission of energy as electromagnetic waves or moving subatomic particles, especially high-energy particles that cause ionizing. Now, there's a good chance you have no idea what I just said, so let's break it down. Ionizing radiation is a kind of radiation we're talking about. It is produced by unstable atoms. Unstable atoms have an excess of energy, mass, or both. It can also be produced by high-voltage devices like an X-ray. These atoms have unstable nuclei, making them radioactive. The atom, in order to reach stability, it gives off or emits an excess of energy or mass. The emissions are called radiation. There are 2 kinds of radiation, electromagnetic and particulate. Gamma radiation and X-rays are examples of electromagnetic radiation. Beta and alpha radiation are particulate radiation. The difference? Particle radiation is the radiation of energy by fast-moving subatomic particles, while electromagnetic radiation is radiation released by electromagnetic processes. The even simpler difference, electromagnetic is reaction to something happening like a large use of energy quickly, while particulate radiation is caused more by particles that have been decayed or through nuclear reaction. Particle radiation is a radiation nukes make, and as a final statement on radiation, no, it will not give you any superpowers like in movies. It will destroy your DNA. This can affect you, but it usually attacks your reproductive system. What does that mean? Well, it won't mess with your internal DNA as much as it will your offspring, which means your children will have a much higher chance of being malformed or having some kind of problem. And yes, radiation will kill you. It weakens and breaks the DNA, either damaging enough cells to kill them or causing them to mutate in a way that may eventually lead to cancer. So no, radiation does not work like it does in movies. Stay away from it.
Now that's all for nuclear proliferation for now. As an afterthought, I'm going to be adding this segment, as this was made for a class project and it's much harder to tell where some of the points are. So I'm going to be pointing out where the quotes are and where my connections are. Let's start with the connections. PS3.A, definitions of energy is everywhere I talk about radiation, as radiation is energy. PS3.B, conservation of energy and transfer of energy is everywhere I talk about nuclear explosives, and explosions are the rapid release of energy in an extreme manner. PS3.C, relationships between energy and forces is also wherever I talk about nuclear explosives, as a nuclear explosion, when it goes off, it turns a massive amount of energy into force. PS1.A, structure and properties of matter, is anywhere I talk about radiation or anything nuclear, is both, as I state, are not stable. Next are quotes. I have 5 quotes in total. I'm not going to quote them because you can go back and see where they are. 3 are when I'm talking about the Nuclear Proliferation Treaty, as it was taken directly from the text, and some sites directly quoted it, and I had to quote them. I have 2 quotes on radiation, as they were said by somebody else, basically as best as you can say them right now. So, I have 5 quotes and 4 standards discussed. Thanks for watching. Hope you enjoyed.